slides. I hope it will work. So today we don't have that much time. It's a lunch seminar, a lunch webinar, again, online, and it's about AquaClim, one of the research schools that has the aim to build a better climate with water research. You can see here the 4 clusters that are collaborating in AquaClim, the 4 Swedish water research clusters, and also the financiers, which is Swedish Water and also Formas. I got here a lot of information from Catherine, who's supposed to do this presentation today, but I will shorten a little bit, and so I will try to take up the core. AquaClim has been actually started in 2016, and also it's administered by Lund University, and it started with a number of courses and also around 20 doctoral students connected to this school. Today is Catherine Paul, who cannot be here, unfortunately, on this webinar, who is the director of the AquaClim since 2020. And the funding came directly from Svensk Vattenutveckling. Nowadays, there are a lot of more PhD students connected to this. And since 2022, Formas also came in with funding. And actually even to fund 5 fully funded PhD student positions within this school. Let me see. I hope you see my next slide now. So what is the AquaClim about? So the research school is basically it's connected to Formas agenda. And there is not only AquaClim, there is 5 different research schools in Sweden, and it's all about to lead the transformative and sustainable urban planning. Basically, the link that you see here up to the left, you can see the agenda on the Formas with the different 6 themes. Beside of one of them, sustainable public transport for all, AquaClim addresses 5 of these 6 themes. So since drinking water and sanitation is essential for a working society, it is crucial actually to contribute to these themes through sustainable communities, which is here hållbar boende and vistelsemiljöer, human health and well-being, down, människors hälsa och välbefinnande, sustainable consumption and production, sustainable water and land use, and safety and security for humans and society. So the agenda Formas includes 5, of this agenda, AquaClim includes 5 perspectives, and this is actually the basis for the courses that AquaClim is offering. The newest going on here with the topics is about machine learning courses early in 2023, and right now it's in process to build courses in other topics as well. The partners of AquaClim stretches actually from Lund to the south to Luleå up in the north. And this is also a challenge, according to Catherine, because the steering group can be mostly online, meeting online. And the courses, on the other hand, because of this variety, are offered in the different locations. The 5 PhD students funded by AquaClim are also geographically distributed. These are connected to Lund University, Chalmers, Luleå University, and KTH. Not only universities, but also utilities are linked directly to AquaClim, which is VVAP in Varberg and Falkenberg, Sydvatten, Uppsala Vatten, Klassipo Vatten in Gothenburg, and Lumire. So although these are only the partners, but of course the relevance of the research school is hopefully addressing much larger groups of utilities connected to the Swedish water and research clusters. So that's why it's important to present today the purpose of AquaClim. Now, Another information here that I got is that within the 5 research schools funded by the same funding call, there is also another research school that is addressing water challenges and is also linked to Svensk Vatten. This is WATCH and is located in Örebro and Karlstad University and addresses slightly wider perspective of water challenges in the built environment. These are more or less the structure of this WATCH school, basically. So it's an umbrella of sustainable planning and built environment, where it describes actually the areas they are interested in. For more information about this, you can contact Ida Andersson at Örebro University or just contact Catherine Paul, the director of AquaClim. I will not go into this more in detail. Now, when it comes to AquaClim itself, the operative work is divided in different work packages that you can see here, AP 1 to 5. Lund University has the coordination responsibility, while activities in the remaining 4 work packages are distributed across the partners. Today, there are more than 75 doctoral students in actually like connected to AquaClim. And these students are all affiliated with one of the research clusters and have salary funding from other sources than AquaClim. For example, there are industrial PhDs or others funded by Formas or Svensk Vatten. As I mentioned earlier, AquaClim is providing funding for 5 PhD salaries, including salary for supervision. And 2 of these PhD students you will meet today. We are very happy to have you here, Shruti and Letty. Because AquaClim has the mandate to transform society to be more sustainable, each AquaClim doctoral student has several supervisors, and this is something special maybe of the research school. There is an engineering supervisor based at one of the universities, and this person also sits in the steering group of the Water Research School. Then each of the PhD students has a supervisor from one of the utilities to provide the real-world perspective. And there is at least one additional supervisor from a complementing discipline, such as mathematics, economy, or architecture. More information is coming in the next slides about courses, and also thank you all for listening today. These are the words of Catherine, and to help actually building the networks between the students and the utilities, as well as industry partners. AquaClim wants to do research that matters and improve society as soon as while it's actually processing with time. So communication and networking activities are very important for AquaClim, and Catherine wants to use the opportunity to thank also Sahar for organizing, and also for the PhD students to being here today. Now, about the PhD, basically the core PhD projects, the 5 doctoral research projects were designed to cover multiple themes in the agenda, but also connect and overlap with each other. And here you see these core research projects. DRP1 is about sustainable production and delivery of drinking water by understanding biofilters and biofilms. DRP2 is about minimizing waste of the drinking water as it is delivered. DRP3 you will soon hear about more from Shruti. And DRP4 you will soon hear also about from Letty. And finally, DRP5 is about how wastewater treatment can be designed to recover novel resources while also being an attractive part of society. Now, we like to say that AquaClim is trying to improve the sustainability of the industrial parts of the water cycle, and this is the picture that is actually summarizing this. You see from the drinking water to water resources, drinking water intake, down to actually the wastewater and also resource recovery. It should be a holistic picture that also AquaClim is working with. Now, courses, they are already planned up to 2027, and this QR code hopefully works if you are scanning it to see the courses at the website, I believe, of Lund University. The courses that are offered are between 3 and 6 courses per year. And these courses are open to all doctoral students, but also to all members in the research school. And they are also open to people from utilities and companies, if you're interested. So as the funding of AquaClim is for doctoral education, it is applied a course fee for other participants who are not doctoral students, and this is 10,000 crowns per course. As I said, so all courses are planned until 2027, and please check the website at the QR code with more information. It's actually a continuous update of the information ongoing, and some courses may be added, and some courses might be actually offered with some change or substituted. Now, beside of the courses, other activities are that is actually crucial for AquaClim is annual meetings for members, mentor program, which is under construction, doctor-student networking, and more ideas are right now also in the process. AquaClim is developing and working to offer other activities exclusively for members of the research school. Catherine says that we meet every year together, and we were in Luleå last year in February. We're working to reboot a mentor program and create online opportunities for more networking. Now, about the people of AquaClim, who are the people behind. As I mentioned, Catherine Paul from Lund University, supported by communicator, project manager Babs Kunle. Unfortunately, I didn't get a picture from Catherine. She's the leading of the steering group, responsible for communication about AquaClim to outside and also to Formas, supports main supervisors for communication to clusters about all activities in AquaClim, organizes communication and website, and structures course information and deadlines. The main supervisors in AquaClim are supervising right now the PhD students are Sahar Dalame, who is actually sitting on 2 different universities now, Uppsala and KTH, Thomas Pettersson from Drix, Chalmers, Karin Jönsson, and Anneli Hedström from Luleå. They are members of the steering group responsible for communication between all co-supervisors and doctoral students, and also responsible for communication to clusters about all activities in AquaClim. They are also the project managers for the doctoral projects. Furthermore, is the industry supervisors that we talked about it. They're really important. Here has been a tricky process, according to Catherine. It would be really appreciated the time that the industry supervisors are putting in and contributing into the projects. And the idea is that the utilities can steer the research questions in the projects via this person. So many of them have changed since we began the project, says Catherine, but we are planning the meeting in the fall 2025 to reconnect with these supervisors. And then last but not least, the co-supervisors that are providing another layer to this, to the projects. They are responsible for ensuring an alternative disciplinary aspect to the doctoral project and also responsible for other disciplinary training for core students. Now, just very short, before I let the word go on to actually Shruti and Letty, the different projects these in these DRP 1 to 5 are the following. Hållbar produktion och distribution av dricksvatten med biofilter och biofen, drinking water production. This is about the project is about how will the function of biofilters change in a different climate? How can we adapt them for the next 50 years? And if we understand how bacteria leave the biofilm, can we optimize pipe commissioning to reduce flushing? And of course, here you see the involved partners and financiers. The next DRP2 is about minimizing loss of drinking water on its way from the production to the tap. What cost-effective strategies can reduce loss of drinking water caused by pipe leakage during delivery? The main question of the project. And how can the water be efficiently used by the customer without compromising safety? With the partners and the universities connected to the project. DRP3, vattenåteranvändning för annat än dricksvatten i Sverige. So water reuse for other than drinking water in Sweden. What are the existing and future needs and potential for wastewater recycling in Sweden is the main question of the project. And what are the regulatory frameworks, social and institutional forces and challenges influencing implementation of wastewater recycling schemes in Sweden? And DRP4 is about samla och flytta resurser i avloppsvatten, so resources from wastewater. How can a transition to sewers transporting black water from the toilets, grey water and stormwater be achieved? Which source separation technologies would be resource efficient in relation to material use, CO2 emissions and other environmental impacts? And at what spatial and temporal scale can these triplicate systems meaning black water, grey water and stormwater, become economically reasonable? And finally, DRP5, design for reuse of resources from wastewater. And what types of resources could be extracted from wastewater and how much can be extracted is the main question of this project. Can these facilities be designed and as functional and attractive public spaces to combine water treatment and recreational use? With that said, here are some more contact informations, and this was my last slide. Thank you. Catherine was putting this together, the slides. So thank you, Catherine, also for these informations. And if you have more questions, more detailed, please contact Catherine, not me. Here you see her email address at Lund University, and also can scan the code to come to AquaClim directly. With that, I would like to invite Shruti to actually share your slides, and please tell us, of course, from which cluster you are from and which project you are connected to. And after Shruti, we take in Letty, and we have time more or less, 10 minutes maximum for a few.
Can you see the screen?
Thank you. Yes, we see your screen, not in the presentation mode yet, but we see your screen.
Yeah, just a moment. Now, is it fine? Now, can you see in the present?
Yeah, it's not the screen that you want to share because it's the.
I think it's a different screen. Just a moment. Give me.
Exactly. Try it again.
Just a moment. Is it fine now? Or?
Yes. Yes, perfect.
Yeah, okay. So good afternoon, everyone. And my name is Shruti Jagtab. I am a PhD student with Sahar at KTH. And so as Helen told us earlier, so this is the DRP3, and the topic is about utilization of reclaimed water for non-potable uses in Sweden. For the reuse purposes. So the agenda is like, what is the background, motivation, what are the key objectives of the project, and what are the expected outcomes and challenges. Yeah. So starting with the background, so we all know that water scarcity and the increasing demand for the sustainable water management have become a pressing concern, like globally and including in Sweden also. So while Sweden is often viewed as a water-rich country, it has experienced periods of water shortages, particularly in the summer months and also during 2018. And so this has so the municipalities has restricted the water use for the irrigation, and also the climate change is expected to worsen these issues, creating a need for more resilient water management strategies. So one such strategies is wastewater recycling, which has the potential to elevate the pressure on the freshwater resources by providing some sustainable source of the water for non-potable uses. In this case, it would be industrial or maybe agriculture, urban irrigation, and potentially for drinking water. So in Sweden, municipal wastewater treatment plants release significant quantities of treated water, and it is into the Baltic Sea, you can say, and it contributes to the eutrophication. And if we use the reclaimed water, the country could not only reduce the environmental pollution but also enhance water scarcity and promote a circular economy. So one of the primary motivations for this research is growing need to explore how the reclaimed water can be utilized for various purposes. And this requires a thorough assessment of the technical viability of different treatment methods, and also an evaluation that is necessary, for the infrastructure and also the water quality standards. But from an innovation point of view, there is a growing global interest in using the electrochemical treatment methods. So this not only have the potential to improve the reclaimed water to the drinkable standards or like high quality water, but also enable the production of hydrogen production as a valuable byproduct. So this dual purpose will actually upgrade the water quality while simultaneously generate the clean energy, which is the heart of this particular project. And by using such electrochemical methods, we can address both water and energy in a single process. And lastly, this research strongly aligns with the Sweden's broader sustainability goals, and by reducing the dependence on freshwater sources and promoting the use of green technologies. So my research is driven by several key questions that aim to address the technical, regulatory, and societal challenges surrounding the use of reclaimed water in Sweden. So the first would be exploring public perceptions and regulatory gaps. So identifying the existing gaps in Sweden regulatory frameworks for water use, especially for various applications, as mentioned earlier, and then apply MCM. I would discuss that in the later slides. And the second would be the evaluating technological and economical feasibility, like conduct feasibility studies to explore the integration of into the existing systems and to analyze the trade-offs and across cost, performance, and sustainability aspects. The third would be understanding social and institutional forces. So basically, we want to know that what are the economic drivers and legal barriers that either support or they are the problem for large-scale implementation of the reclaimed water for both non-potable users and potential potable users. And the last would be assessing environmental and system level sustainability. So here, I'm planning to conduct a comparative LCA, life cycle assessment, of the conventional wastewater treatment and the system integrated with hydrogen and oxygen recovery. So evaluating the environmental and energy impacts would be helpful. So yeah, so this is the phase one. As shown in the last slide. So this is like, I'm going to go in a bit detail. It's like exploring the public perception and regulatory gaps. So the first key component of this is a survey, which is aimed to understand the public perceptions of reclaimed water reuse. And the public acceptance is really crucial. for the success of any wastewater recycling initiative, especially when it comes to various reuse options, like for industry, or maybe being it for toilet flushing or for direct potable reuse. And there is often a hesitation about the drinking water, like that is actually derived from the treated wastewater. So through this survey, I'll collect the data on how people feel and about the idea of the reclaimed water, what their concerns actually are, and what factors might influence their acceptance. For example, is there something threshold of treatment that they would be comfortable with, or what type of uses they prefer, such as irrigation, maybe industrial purposes, or any other which they are willing to accept as compared to direct human consumption. And in addition to these perceptions, the survey will also help us to identify broader social challenges, and also the regulatory framework part, because the regulations, we need to know that if the regulations are sufficient for guaranteeing safety, and are they flexible enough to adopt this emerging technologies, like I mentioned in the last part, the electrochemical methods. And to analyze this survey results, I will apply multi-criteria mapping. It's a decision-making tool that allows us to weigh various social and regulatory factors based on the stakeholder priorities. So this would be the phase 2. The second component, it involves experimental work on electrochemical technology for wastewater treatment. And this electrochemical methods, they have the potential to treat the wastewater to a high standard, possibly even making it suitable for the potable users. And these are really promising because they can remove the contaminants more efficiently as compared to the conventional treatments. And they also offer the possibility of generating useful byproducts. So one key area I want to explore is the use of this electrochemical water treatment to achieve the drinkable water quality. It is so basically this would involve passing an electric current through the water to break the pollutants, and including the organic matter. And then after fine tuning the process, I hope to develop a reliable system that can produce the safe drinking water from the reclaimed water. And in addition, these technologies also open up to possibilities of the hydrogen production as a byproduct of electrolysis process. So basically, this is a clean energy source and can be generated through splitting of water molecules. Yeah. So by producing this hydrogen alongside the water, high drinkable water quality, we can address two sustainability challenges at once. And the feasibility of using this electrochemical technologies in real world application will be the key focus of my experiments. And the third would be social and institutional forces. This would address the social and institutional forces that shape the implementation of the water use strategies currently in Sweden. And technological success and public acceptance alone are not enough. We need to understand that how these institutions actually make the decision, or how the policies evolve, and how the actors across the systems interact with. And to explore these dimensions, I'll conduct interviews, also the group discussions with key stakeholders, and this would be in depth. So the goal is to understand that how this decision, so basically decisions around the innovation, as mentioned in the last part, and the infrastructure is made, and how I can bridge the gap, and what are the values, rules, and practical concerns that are driving or limiting the change. And yeah, the final aspect would be LCA, which will compare the environmental impacts of traditional wastewater treatment process with those that incorporate the hydrogen and oxygen production from the electrochemical methods. So LCA is a tool that evaluates the environmental effects associated with all stages, being it product or process, right from the raw material extraction through the production and use disposal. So I'll assess both the environmental impacts, and also the energy use and emissions and indirect benefits of generating the energy sources. So the production of hydrogen as an energy source could reduce the carbon emission, and it will replace the fossil fuels in certain applications. And so by conducting this, I aim to provide a understanding of like how these integrating reclaimed water with hydrogen production as like a valuable source can be used against the traditional water. So these are the expected outcomes, like the social insights, then the technological advancements, the potential hydrogen production, and environmental impact. So yeah, in the final section, I would just like to highlight that one of the biggest challenges in using reclaimed water is navigating the existing regulatory framework. And these technologies are really great, but these are not only proving that these technologies can work at we have to prove that these are not only this work at the lab scale, but also can be scaled up effectively for a industrial or maybe municipal use. And last but not least is the public trust. So just to sum up, I want to say bridging the technology, policy, and the public trust remains the key challenge. And through this research, I hope to contribute meaningfully to that journey. So yeah, I think that's all about the DRP3. And thank you for your time and attention.
Thank you, Shruti. Thank you. We actually switch right away to Letty because of the time constraint. Thanks a lot. It was very interesting to see, especially the circularity of your project and of your research. Best of luck. Your time plan, Shruti, is basically in which year are you?
I've just completed my 6 months.
Yeah. You're at the beginning of your journey.
Yeah, beginning.
Thanks. If there are questions, please write it in the chat, and while we are waiting for Letty to share the presentation.
I don't know if I'm sharing right now. No?
No, it's not yet. It's another screen somehow.
Oh, okay. Now?
Yeah, that looks really good. Yeah.
Yes, okay. Okay, good afternoon, everyone. My name is Letty Mora, and I'm a PhD student at LTU, Luleå University of Technology. And my project is called Triplicate, from duplicate sewers to source separating wastewater systems. Right now, like wastewater is increasingly seen as a sort of nutrients and energy, especially when we have this kind of system divide into black water and gray water. And the reason is because, for example, if we do that, we can recover from 60 to 70% more energy in terms of biogas and 3 times more phosphorus and 3 times more nitrogen. So it seems that these kind of systems are sustainable. But it's super common to hear opinions like this one. It's more complicated, it's more expensive, no real benefit. Is conventional system work well? Why do we need to change to another system? And it's particularly these kind of opinions that are the motivation to increase the knowledge about this kind of system, because there are not guidelines about building and operating source separating wastewater system. And the situation is even worse when we want to implement this system in existing areas like the city center, for example. So that's when Triplicate pop up. But what is Triplicate as a project? It's a project that aims to increase the knowledge about source separating a wastewater system. Otherwise, we will continue to use the same system than conventional ones that were introduced so many years ago. It's also a project that goes beyond proposing this kind of system, source separation, just in new areas. Our focus is existing areas. And we have 3 main objectives. The first one is to analyze in which context triplicate system can be resource efficient in relation to material use, CO2 emissions, and other environmental impacts. The second one is related to the economic perspective. And the third one is to analyze the drivers and limitation of the transition, so from conventional system to source separating wastewater system in existing areas. So how and when existing buildings should we connect to this system? And in the group, we think that renovations are windows of opportunity. So we want to evaluate if the renovations are really a windows of opportunity for this kind of systems. So far I am in the second year of my PhD. journey, and I have divided my PhD into three main groups. And the first group involves two studies, and it's about the main sewer network, so outside the buildings, the ones that are in the roads. The second group involves the economic analysis, two economic analysis, and are gonna base in the building, so inside the houses. And the final group is also my final study. In this study, I want to evaluate the implementation over time of source separating wastewater system in existing areas. So just a little bit about context for my first and second study that are involved in the first group. The context is that in an area, the existing sewer system is full, so there is no more capacity. And sometimes during melting season, there are overflows. And what is the consequence? Is that new housing areas cannot be built. So the city cannot grow. My first study was a conceptual one, and with the base of the context that I explained, we identified the problem in several workshops. We work with Lumira, that is the local water utility and one of our stakeholders. And we identified the issues about the alternative to implement source separating wastewater system in this kind of context. Of course, the main problem is that there is not much information about these systems. So we conduct a literature review and some interviews, and as a result, we have proposed a framework and some alternative. This framework was tested in one workshop, and the aim of the framework is to provide stakeholders kind of a summary of all the possible alternatives that they can implement in this kind of context. But not just alternative, also we include some considerations and consequences of the implementation of this alternative. And this paper is going to be soon published. Right now, I am working on my second study that is an LCA, and we took one alternative from the first study, and we are comparing that alternative with the conventional system using the life cycle assessment tool. So the alternative that we picked was the one that the black water is going to be collected using vacuum system and is going to be discharged into the existing network and into the existing treatment. So in that way, the water utility don't need to install a new pipe or to increase the diameter of the main sewer pipe. And the gray water is going to be collected by gravity and treated locally. And why this option is because if you treat locally the gray water, you are reducing more or less 75% of the wastewater production. So you can reuse the existing pipe. And at the same time, I am working in my third study that is going to be a discrete choice experiment. I'm working with people from the economic department in the university. And in this study, we are going to provide kind of a survey to different kind of people. And they will have different choice options, and they will pick the best option based on their priorities, right? And also based on the price of the options. So the aim of this study is to analyze the willingness to pay of people in front to implement source separating wastewater systems or not. And basically, we want to focus this study on the social perspective about the vacuum toilets. So I invite you to keep an eye on our publication and feel free to connect with us. Thank you.
Thank you very much, Letty. Really exact in time. Thanks a lot. Very, very interesting. Triplicate. Thanks for that. Since we have exactly 1 o'clock here, but still, if there are any questions from the public, please feel free to ask, since we have you here now, Shruti and Letty. And with that, I will actually stop the recording.